Hello, everyone. And first of all, I'd just like to thank you for being part of this today. And today going to talk about the use of AI for diabetes and really focusing on some of the human-centered challenges and, as the title says, some of the paths forward. So first, a little bit about myself. Like many people, I have many roles, identities, interests in my life. Some of them that might be relevant today. I myself have diabetes. I've had diabetes since I was 13. And unfortunately, I seem to have passed it on to one of my children who's doing very well. She's now 19. She got diagnosed at 13. Along with that, I also do consulting. I'm an HCI researcher. I do design work. And some of my interests include ethics, especially digital ethics, digital health. I'm very interested in startups, doing some research around the use of machine learning to support some disabilities. And exercise, although I've never been a great athlete, has always been important to me throughout my life. So, just a quick outline for today. We're going to talk some about diabetes self-management. Then we're going to talk a bit about the use of machine learning for diabetes, some of the failures and paths forward, human-centered design, and then we're going to bring this all together to talk about how we might move forward. So very briefly, diabetes is a chronic health condition. There are two main kinds, type 1 diabetes and type 2 diabetes. I myself have type 1 diabetes. That means my body produces essentially no insulin. And as many of you probably know, insulin is very important for allowing sugar to move out of your bloodstream and into your cells. It's kind of like the key that opens up the door to allow that transition. And without enough insulin, your body can't get the sugar it needs to work, and it builds up to dangerous levels in the bloodstream, causing all kinds of long and short-term problems. Very brief description. So, in terms of diabetes worldwide, the question is this a big problem? And the easy answer is yes. We're talking in terms of the number of people, 537 million people now, and going up. It's predicted, according to the IDF, they're predicting heading up towards 780 million people in the not too distant future. Right now, it's close to $1 trillion a year being spent on diabetes related complications, many millions of deaths every year. And it's not, whereas once it was thought of as a condition of the wealthy countries, now the majority of people with diabetes or pre-diabetes are now living in developing countries. So what do you do if you have diabetes? And this is fairly similar for both type 1 and type 2 diabetes. There are essential behaviors that you need to do to maintain your health. So eating well, being active, monitoring, problem solving, coping, taking your medication, reducing risks. And of course, interestingly enough, these are all the sorts of things that, for the most part, everyone needs to do to stay healthy. It's just especially important for people with diabetes. So, the challenges of diabetes is that the blood sugar is always going up and down. And as a person with diabetes, I'm trying to maintain my blood sugar in as close to a normal range as possible. So, this gray zone might show you a normal range, and keeping in mind that everyone's blood sugar is always going up and down. So for example, after you eat, your blood sugar goes up, then your body produces insulin naturally from your pancreas, which helps bring it down. And if you don't have diabetes, your body system does a good job of maintaining in this level. If you're unable to maintain this level, well, then you have diabetes. So what makes it difficult as a person with diabetes is that all kinds of things can cause it to go up and down. So, for example, if I exercise, that uses energy, so that reduces blood sugar. It also increases the effectiveness of the insulin. The insulin gets moved around a lot better when I'm exercising. Stress can increase it. Fats can delay how long it takes for you. For example, pizza is very difficult for people with diabetes because the fats slow down the absorption of the carbohydrates. So, for example, what's known as a real challenge for people with diabetes is you eat some pizza, you go to bed, your blood sugar's perfect, and then at 4 in the morning, you're sky high because by then the carbohydrates have been digested. And I find, for example, for myself, that if I eat a lot of carbohydrates at dinner, the next day might be quite difficult. So it can take quite a long time. Now, technology has long played a role in diabetes management. So, for example, here's some of the early systems for blood glucose monitoring. And you can see this up in the upper left-hand corner, there's a black one sort of behind the orange one. That's an Ames dextrometer. That was the first meter I had when I became diabetic. And that was, by today's standards, a pretty primitive meter. It had to be plugged into an outlet, so no battery. You had to wash the strip with water, and you had to use a strip for every blood test. Now, that's moved along. So when you look at blood glucose meters, these are, for example, typically used by people with type 2 diabetes. You still need to use a strip for each test, but they've gotten much smaller, the battery powered. And then more recently, we've gone to continual glucose monitors, or CGMs. There are a few out there, but it is at the moment essentially a duopoly with Abbott, which is not exactly considered a CGM. Well, actually, I guess it is now with the new one, and Dexcom. And here they're continually taking measurements. So for those of you interested in machine learning, this is, of course, a much better data stream because with the previous meters, someone might do 4 or 5 tests a day, and now we're getting a test every 3 to 5 minutes. So it's a much fuller picture. It's much better for prediction and so on. There's also insulin pumps and to help with continual infusion of insulin. And then there's apps which help people to understand this complex data, all these various factors. Now, when I started my PhD, I could have mentioned I did my PhD rather late in life. I was in an entirely different field before and wanted to move along and started doing research on diabetes. And when I first started my research, I was looking at diabetes apps and I was trying to figure out why do people stop using them. So because I was in HCI, one of the things we do is we go and we talk to people. And this was just a pilot study. It was published through Springer. And what I found in here was that very few people were continuing to use diabetes apps over the long term. The adoption levels were really low. And at this time, this 2014, social media was really hot. And of the people I asked, the great majority were using social media apps every day, but they weren't using the diabetes apps. And this was pretty interesting. Why, for something that was so important, your health, why were people not using the apps, whereas they were using them for interacting with their friends and so on? So I think one thing that was really useful for me was trying to understand how people think, how they make decisions. So if you're not familiar with this, Thinking Fast, Thinking Slow, Daniel Kahneman, I think he won a Nobel Prize on this, something like that. And he talks about a dual process model, which is that people make decisions in 2 main ways. System 1 thinking, which is very emotional or fast, using heuristics or mental models, and often, so this is quick processing. And system 2, which is logical, systematic, but takes a lot of energy. And the idea is we often default to system 1 because system 2 is expensive, right? We have to really think a lot, and in general, we try and avoid that because we have to conserve our mental energy. The brain uses a lot of glucose when it's thinking a lot. So if we look at apps, the most popular apps, I would present to you that for the most part, the smartphone is a system 1 device, largely, not entirely, but largely. We're looking for things that are easy to do. Don't make me think too much. And diabetes apps really weren't this kind of an app. They didn't tell you what you needed to know. They just presented you a lot of data, and it was a lot of work to figure out what it meant and trying to record all the data. And it didn't feel good to see that you weren't doing well. And these first generation of diabetes apps, which are largely still how diabetes apps look, for the most part, people didn't want to use them because it was just too much effort. What does this have to do with machine learning? I'm getting there. Okay, so uh, the next move, and this has really changed a lot since I started my research, is automated insulin delivery. So originally it was called like the bionic pancreas, or um, what were the other names? There were other names for it, but the idea here was that um, you would build an artificial pancreas through the use of combining your glucose monitoring, your insulin pump, which gives you the insulin, and then an algorithm, which would measure how you were doing and then giving you more insulin when you needed it or less insulin when you didn't need it, when your blood sugar was going down. And at first, there were patient organizations which really pushed this forward, and now there's a number of commercial companies that are producing this as well. Several have now been given FDA approval, and there's a lot more on the way. So, given this huge change in diabetes management that's happened since I started my research in 2013 through 2014, so you might ask, well, isn't diabetes solved now? And I think the proposal I'd say is there's still a lot of work to be done. First of all, these systems are very expensive. It's really important to remember that in a lot of places in the world, people are struggling just to cover the cost of insulin, let alone the cost of the disposables for the pumps, the continual glucose monitors. So these systems, although they are life-changing for many people, it's still a fairly small percentage of people who can afford to use them on a daily basis. I think there's also some interesting questions around autonomy, how systems like this might cause people to not to become disengaged with what they're doing in their lives and not really thinking about it. There are a lot of context and variables that these systems really can't capture. So right now they're primarily going they're functioning by taking in what is your current blood glucose level. You tell it how much you're going to eat, and it then gives you more insulin. But it's still a very limited picture if you think of all the things that can impact blood glucose levels. And of course, there's a lot of personal factors, reasons why people might not want to use these systems. So, what are some of the areas that AI could still help diabetes? So, there's still an issue around how much medication to take. These systems do use primarily not AI algorithms, or not machine learning algorithms. They use, for the most part, very old algorithms, which are good because they're traceable, they're transparent, but they're still limited. There's still a lot of space in terms of personalizing suggestions for all the variables that can be impacting insulin needs. Um, Warnings if you're getting too high, too low, prediction on that's a big area of research. And how can we reduce complexity of all this data? Is there some way we can help bring together all this data and help people to understand their data and make it easier for them to make good decisions? Now, I would just like to inject a word of caution here and go over a study that was published last year. I was a co-author on this. I wasn't first author, but I helped. I was the only person with diabetes on the project, for example. And this was human-centered research trying to look at the use of machine learning to support diabetes. And this started with some pretty common approaches, which was basically what sort of information can we collect to feed into machine learning algorithms to help give people insights. And the first question was, what would people be willing to track? Because we know there are all these different things that can impact. So the first part was asking people about this, and they got an Apple Watch and they got a CGM, and we worked with people trying to figure out um, how we could design these systems to help support. And unfortunately, it didn't really work. And one of the big things that came up was that it's a lot of work tracking all these things. You can't automate it all at this point. A lot of it needs to be hand entered. And most of the time, people, now, not when they first get diabetes, but after they've had diabetes for a while, um, most of the time they feel pretty in control. Most of the time they know what to do. Maybe their blood sugar's not quite right because they ate something they probably shouldn't have eaten, but they understand what's going on. So that means that a lot of the times they don't have a lot of motivation to be just collecting tons and tons of data all the time. And the situations where people really wanted the support, the digital support, the algorithmic support, was in unexpected situations where they didn't know what's going on. But this brings up a big problem, which is big data approaches require a lot of data. And in an unexpected situation, that person doesn't have a lot of collected data because by definition, it's something that hasn't happened a lot. And if it's happened a lot, then they've built up the mental models to know what to do. They've built up their system one processing, their if this happens, then do this. If I have low blood sugar, to eat 15 grams of sugar and wait 10 minutes, this kind of a model. So we ran into a problem that these big data approaches depend on feeding tons and tons of data, but the people don't want to do it because it's too much work, and most of the time they don't need it. So some study takeaways were that there's a lot of different kinds of situations that people face, and that diabetes decision support systems can't just be a master system for everything. They want different kinds of support in different kinds of situations. It's contextual. And that where they most value it is where they don't have the personal heuristics, and that and you can read this paper to see how we deal with it, but that future systems are going to have to require a combination of systems for different kinds of needs in different times. So just getting the huge data set and solving diabetes, probably not the path forward. It's more complex than that. And just a lesson on this. I don't know if anyone followed IBM Watson, which crashed and burned a few years ago, but this was really IBM Watson. They were going to take the big data approach and they were going to solve everything. And at the end of the day, there was very little to show for this. I remember they were working with Medtronic, who is one of the leaders in diabetes hardware, and they came out and said, we're going to have these great insights. And then you just didn't hear very much, and it just didn't really go anywhere. And some people have written about it. IBM Watson then ended up getting sold off for almost nothing to various companies. And some of the issues that, for example, this article cited here talked about was they didn't have the specific domain knowledge they needed. The data set quality wasn't good enough. They weren't really focused on real world. Real world is much more complicated than laboratory conditions. They really pushed the hype, which doesn't always work very well in chronic disease management. And as part of that, they were looking for the big positives and not being willing to accept the critical feedback. So I want to just kind of go over some of the principles of human-centered design for you. So it's really important if you're doing human-centered design, and I use the term human-centered design, but there's a lot of different terms. It could be user-centered design, co-design, participatory design, contextual design, or what's very trendy the last several years, design thinking, but it's all kind of talking about the same thing. It's about really understanding your users, what they're doing, where they're doing it. It's about working with your users throughout your process, getting their input. It's not enough to have a system that works in theory. The user has to be willing to use the system, especially if you're doing something like this for a chronic disease where the people are doing most of the management themselves. Your design is driven and refined by this process. Okay, you have to be willing to drop your ideas and change them iteratively as you progress along. And you really have to design for the whole user experience, how people think, how they feel around their concerns, their emotions. These are all important. And it's a multidisciplinary effort. You can't just do this with engineers. You've got to have people who understand the people. You need to have the people themselves involved. You need the medical professionals. You've all got to be working together, bringing your skill sets in. Now, in terms of what this means for if you're interested in the use of AI or various AI techniques, machine learning for chronic health conditions, some of the things you need to take in mind: your data quality is essential. All these systems work on data and finding patterns in data, obviously. So the quality of that data matters. And it's not enough just to dump in a lot of numbers, garbage in, garbage out, right? Emotional sensitivity, you have to understand how people feel about it around the recommendations they're getting. If you upset your users, your system is not going to go. If you're asking questions that they don't want to answer, you're not going to get the information. You need actionable insights. It's not enough to get an insight that people don't know what to do with. You need something that allows them to change their behavior, and an insight towards a behavior they're willing to change. These both need to be true. If it gives them too much burden or workload, forget about it. They're not going to adopt. So there are many other conditions, but these are some of the issues that you really need to think about if you're designing a system. And that's to emphasize. That means that you really need to have your users integrated. The people who have these conditions, the people who use these systems, they need to be integrated throughout the whole system. It's not just about the data. Okay? And in conclusion, I would like to just briefly discuss sort of a technocentric versus a human-centered approach. So I was asked to help with a project which didn't get funded, where basically they thought that user-centered means that that was about how do you get people to give you all their data. That's not a human-centered approach. It's not just about convincing people to give over, to let go of their privacy and give you all their data. A more user-centered approach might be about thinking about how do we reduce the effort needed for people to learn less biased and actionable heuristics for situated decision making. What do I mean by that? People don't want to have to rely on this machine all the time. How do you help people to learn how to do things better? How do you help them to see insights, but you've got to reduce the effort? So, for example, with that first generation of apps, it was all about just graphing data. That's not enough. You have to have the insights, but it's really important that people are learning, that they're integrating what comes out of it in a way so that they can make better decisions for their own care. So here's me. If you want to get in touch, please feel free. I list some of the papers, and I think hopefully you got sent these. You could Google Scholar me too. If you're looking for something specific around diabetes or various other areas around user-centered design, please feel free to get in touch. Always happy to discuss literature with people. So to that, at the end there, I will hand off to the next person.